Hello student, welcome to the second lecture of our classical mechanics course. In last lecture, we had discussed about the Newton's laws of motion, and in that we discussed various phenomena in physics like space, time, force and mass. After that, we thoroughly discussed the Newton's three laws of motion, in which we derive the equation for the motion. For the second law, we thoroughly gone through this first law of motion with their examples. So with the help of Newton's laws of motion, we can analyze various things happen inside the nature. So based on the Newton's laws of motion, we can find the various areas of technology where you can use these Newton's laws of motion in order to solve this problem. So one of the basic problem which can be solved with the help of Newton's laws of motion is the motion in 1D. So as we know, these kinematics is another branch of mechanics, we can say, where the study of motion of the object, but in kinematics we are not supposed to worry about the what is the source of force, how this force supposed to change the motion of the particle. So where in 1D we only deal with the motion of the particle, change in the motion of the particle along the particular one dimension. So suppose if we consider the motion of car, suppose traveling in the 1D along the x-axis, we can say. So in that case, suppose if you consider the frictionless surface, if you consider there is no friction between the road and tire of the car, so in that case car supposed to move for a long time with the uniform velocity. So this is the Newton's first law of motion. Second, if we consider the free fall, so in that case body dropped from a certain height and it follows the path from vertical direction to the ground. So in that case body move with the constant acceleration, and the constant acceleration is g. So g means acceleration due to gravity, and these gravity with these acceleration body move with vertical direction. So this is how this 1D motion we already seen in our kinematics lecture, and in that we derive the three equations for the kinematics for the motion along the x-axis as well as motion along the vertical y direction. So in that case we only replace the acceleration by the acceleration due to gravity. But if you go beyond the 1D case, there are various processes which occur inside the nature where we have to deal with the two-dimensional cases. So you can say these we are living in the three-dimensional space. Why we are worrying this two-dimensional, one-dimensional case? Because if you understood how to solve the problem in 1D, then and then you can find this problem in two-dimensional case. So the two-dimensional problem can be solved with the help of again Newton's laws of motion. So where we discuss the motion along the x coordinates and along the y coordinates independently, and I'm saying that these two motion along the x and motion along the y, these two component wise motion are independent on each other. So this is a part of our lecture. So what are the examples of these two-dimensional motion? So two-dimensional motion is when we saw a football player, when he kicked the ball, so ball follows the trajectory. Suppose if I have this chalk and if I just project this chalk, so it follows this path. So the path followed by this chalk is nothing but the projectile motion. So projectile motion is our today's talk. So projectile motion is a planar motion in 2D with the constant acceleration. So in plane, when we consider these example of this chalk, so when we project this chalk by making certain angle with the horizontal axis, so it follows this kind of the path. So this is somehow different from this 1D case where we just move the, we apply the force along the particular direction, and we can observe the acceleration displacement of the particle along that particular direction. But when we discuss the trajectory, when we discuss the projectile motion, so in that case, the motion is in these two coordinate system. One is x coordinate and another coordinates is y coordinates. And I'm already told the motion along these two coordinates are independent on each other. So we will see with these example with the graphical representation, where we clearly see how these what are the different characteristics of this projectile motion. But I wanted to say that these two motion along these x coordinates and motion along the y coordinates are totally different. So the motion along x axis is constant velocity motion, keep in mind. So the motion of the trajectory along the horizontal direction is the constant velocity motion, where acceleration is 0, whereas the motion of this projectile along the vertical direction is the motion of constant acceleration. So you can ask the question, why this motion along these x component and motion along the y component are different, but those motion are independent of each other. So I would like to explain those with the help of some examples. Suppose I repeated the same example when we have a car, and this car move with the some force, and suppose the friction between tire and road is 0. So in that case, car move with the uniform velocity along the x direction. So in that case, weight of the car is always balanced by the normal reaction of this car. So in that case, the motion only along the force experienced by the car is only along the x direction. So there is no component of force acting along the y direction, because force acting along the y direction on the car is balanced by these two forces due to its weight as well as normal reaction. So there is no motion along the vertical direction. But when we talked about this motion along the vertical direction is constant acceleration motion, the motion with constant acceleration. So when body projected from this point O, let's say, so at each and every point on the trajectory, body experience the acceleration, and this acceleration is acting towards the earth, and this constant acceleration is g, 9.8 meter per second square. So that's how these two motion are independent on each other. So again, I would like to give some example where we can see the motion along these x-axis in the projectile and motion along the y-axis are independent on each other. Suppose if you have a ball, and this ball, or suppose let's say we have a chalk, and if I release the chalk like this, so in that case chalk follows the free fall motion. And suppose if I release the chalk by pushing some horizontal, by giving some horizontal motion, so in that case chalk follows this trajectory. But my question is whether the time required for this chalk to reach the surface of earth is same or different. So that if you find the answer of this question, you will find the time required in these two cases to reach the chalk from release position to earth is same. So that means if you give some initial velocity to the projectile in the vertical direction, or if you give the velocity of the projectile in the horizontal motion, so in that case body move with the same acceleration. So the motion along the vertical direction and motion along the horizontal direction are totally independent on each other. So as we know, we already discussed these kinds of the problem in our T.Y.B.Sc course, where we already discussed such kinds of the motion. But I would like to explain those terms where we can say these projectile motions, vertical component and horizontal component. If we component wise split this motion, so in that case those two components are independent on each other. So the motion of the particle we can explain with the help of this animation, where we can use the example in cricket. So where batsman hitted the ball and ball follows the trajectory, and the component the velocity of the component of the velocity are split into two parts, one along the x-axis, another along the y-axis. So we can see with the help of this animation. So there are n number of applications in our day-to-day life we can see in for the example of projectile motion. So let us discuss the motion in 1D, and after that we will discuss the motion in 2D, that is projectile motion. So suppose there is football ground and football player hit the ball. So ball move in the 1D plane where its motion is along the only one axis. So in order to represent such kinds of the motion, you only need the one Cartesian coordinate. So that is, suppose in our case we consider the x-axis in order to find the motion of the particle, in order to describe the motion of particle. Only we need the only one coordinate system, that is x coordinates, and with this we can describe the motions, velocity, displacement, acceleration, and all those. So such kinds of the motion can easily be described with the help of Newton's laws of motion. So this is more motion in 1D. But suppose if you want to consider the motion in 2D, we again have to look at these two different coordinate systems, two different axis coordinates for describing the motion of particle. Another example where we can see the motion in 1D is simple, where we can use the Newton's laws of motion and describe its acceleration, velocity, and displacement. Suppose the vehicle moving along the straight line. So such kinds of the motion can be interpreted by the Newton's laws of motion. Suppose in order to analyze the motion in 2D, we require the two different dimension. Suppose consider we have a cricket ground and batsman hitted the ball and the ball followed the trajectory like this. So this motion of the ball when batsman hitted the ball in the vertical direction, so it follows these kinds of the path. So we can see this path followed by this ball is parabolic path, and this path followed by this projectile is nothing but the trajectory of the projectile. And these such kinds of the motion we can say this is the projectile motion, when the projectile body, when projected by making a certain angle with the horizontal axis and reaches the ground at a certain point. And these kinds of the motion, the beauty of this motion is that we can interpret, we can analyze such kinds of the motion by the help of Newton's laws of motion, by analyzing the motion in two different coordinates. Suppose if we consider these such kinds of motion in two different coordinates, in order to identify, in order to describe this motion, we require two Cartesian coordinate system. Suppose vertical coordinate system, vertical Cartesian. Suppose vertical axis is y and horizontal axis is x-axis. So the projectile move from this origin O and makes this trajectory. So the maximum distance covered by this projectile in the horizontal axis is nothing but the range of the projectile. So this is the maximum distance covered along the horizontal axis. So in cricket we can say the maximum distance covered by the ball, and we can say in such case the maximum 6. So this is the distance along the horizontal axis where the projectile reaches the ground. So this is the range of the projectile. Next characteristics of this projectile motion is the maximum height. So how much projectile can reach into the vertical direction. So the maximum height reached by the projectile in the vertical direction is the height of the projectile, or maximum height we can say of the projectile. So when a projectile move in the plane of, let's say, x and y axis, so in that case a projectile makes an angle theta with the horizontal axis, with the x axis, and that theta is nothing but the projectile angle of projection. So this theta is the angle of projection. So this range of the particle is the maximum distance covered along the horizontal axis. Maximum height of the projectile is the maximum distance covered along the vertical direction, and this theta is the uh, angle of projection, which is the angle between the initial velocity of the projectile and the horizontal axis, we can say. So another one parameter is there, that is the time of the trajectory, time of the projectile, okay, or you can say time of flight. So this is the time at which projectile starts its journey from origin and reaches the point of the where it hits the ground. So the time required for this trajectory is nothing but the uh, flight time of the flight for the projectile motion. So this is, so those are the quantities we can say we already discussed in our projectile motion without the air resistive medium. Suppose if you want to analyze the motion of the particle, we already take the two different coordinate system along the vertical y-axis and along the horizontal x-axis. Suppose if you consider component wise how this motion is supposed to be analyzed. Suppose if we have a two Cartesian coordinates, vertical coordinates y-axis and horizontal coordinate x-axis, and the projectile starting a journey from origin and follow the path, and this path is the parabolic we already discussed. So in this case, suppose projectile's initial velocity is v. So this velocity v is in the plane of x and y axis. So this is a planar motion. So in order to describe this motion, we split this velocity, initial velocity, into two perpendicular coordinate system, that is along vertical v sin theta and along horizontal v cos theta, by making an angle of projection theta. Okay, so this is this component wise splitting tells us how these components whether it is dependent on each other or independent on each other. So we talked about these coordinates are independent on each other, and we say this horizontal component v cos theta is the constant velocity component, whereas this v sin theta is the component with constant acceleration. So how these two components are different, let's say when projectile starts its journey from this point, let's say with initial velocity v, and follow this path, and this path is parabolic. So suppose the projectile start journey and reaches the point of maximum height. So in that case, how these vertical component as well as horizontal components behave. So this is the motion of the horizontal component as well as vertical component when projectile starts its journey and reaches the maximum height. But at maximum height, projectile's velocity is 0. So at that point, maximum height where the velocity is 0, and for that point there is no x component and there is no y component. Since the velocity of the projectile is 0 in the vertical direction, so there is no point to talk about this component wise splitting of this velocity. But when the projectile starts its journey from the maximum height to the end point of this trajectory, so in that case how this component is supposed to be divided into two different components. So those are the components, v cos theta along the horizontal axis and v sin theta along the vertical. But you can say previously this horizontal component v cos theta is same as the previous. So direction, magnitude is the same. So there is no change in the velocity of the particle along the horizontal direction. So that's why we are calling these velocity along the horizontal component as a constant velocity motion, whereas the velocity along the vertical component is a constant acceleration, because we can see this initially when we start the journey and reaches the point. In that case, velocity in the upward direction, vertical component of the velocity is in the upward direction. But when the trajectory starts from the maximum height to the end of the trajectory, in that case vertical component of the velocity is in the negative direction. So in that case velocity changes its direction, and when change in the velocity gives the acceleration of body, and that constant acceleration is nothing but the acceleration due to gravity. So keep in mind this velocity along horizontal axis and velocity along vertical axis are the constant velocity motion and constant acceleration motion. So when the projectile starts its journey from the vertical point where velocity is 0 to the end of the trajectory, it follows these path. So where the projectile's trajectory at its horizontal as well as vertical component of the velocity remains same. So with this we can say these two components of the velocity in the projectile motion are independent on each other. So those components, so the horizontal components are the constant velocity where velocity is not changing during the projectile motion, whereas the vertical component is constant acceleration component, we can say, where the each and every point on the trajectory the vertical component is changing, and this acceleration is known as acceleration due to gravity. So at each and every point the projectile feels the gravity and it moves along the earth. So this is all about the projectile motion where the air resistance is absent. So in the absence of air resistance we discuss these kinds of the motion. So in the next lecture we will see the if air resistance is present, so how this motion, how this projectile can be described with the help of such kinds of the constraint on the system. So with these we can stop here. In the next lecture we will start our session with the introduction to the projectile motion in digestive medium. Thank you very much.